Hello, this is video 21. I'm going to go over Newton's second law of motion. This is a very big topic, so there will be many videos that use this law where I show how to do a lot of problems. In this video, I'm just going to introduce it and do one example problem. So before we can talk about Newton's second law, we need to understand what is the net force. The net force is the vector sum of all the forces acting on the object. So you can see in this picture, if you have two 5 Newton forces to the right, then what's the result of that? You can replace those two 5 Newton forces with one 10 Newton force to the right. You're just adding those forces. You can use a tip-to-tail method. You'll get 10. If you have a 5 Newton force to the right and a 5 Newton force to the left, what's the net result? Net result is 0 newtons because these two forces will subtract from each other because they're in opposite directions. And then the last one here, you got 10 newtons to the right, 5 newtons to the left. What's the net force? If you say 5 newtons, you're only half right because remember that forces are vectors, so you need to specify a direction. So it would be 5 newtons to the right. So to represent the net force, we use the summation symbol. Sometimes you'll see net written. Sometimes the problem might say what's the resultant force. It all means that you're adding up all the forces together using the vector addition rules that we've learned in a previous video. Let's do a your turn question. Make sure you understand this idea of net force. This one's a little bit tricky. Let's take a look at it. The net force on an object points to the left. 2 of 3 forces are shown. Which is the missing third force? So the idea is that once you add this force 1, 2, and one of these force 3s, the net force will be to the left. What that means is that whatever force you choose here for force 3 must cancel out the vertical component here of F1 because the resultant force, the F net here, does not have any vertical components. So you can't pick A or B because they're not going to cancel F1. So it's going to be C or D. And then you have to pick, well, if I want a net force to the left, that means that the x component of F3, which I've shown here for both of these, that x component has to be greater than the force to the right to have a net force to the left. So that leaves the best choice as choice C. And now we're ready to talk about Newton's second law. I like to go over a conceptual understanding of it first. So if we look at this picture on the left here, it says that the force of the hand accelerates the brick. If you put twice as much force, you're going to get twice as much acceleration. You know that from experience. The harder you push, the more it's going to accelerate. So this means that the acceleration is going to be proportional to the net force. Proportional means you increase that net force, you're going to increase the acceleration. And then on the other side here, we have that you're pushing a brick, but now if you apply the same force but you have twice as many bricks, then it's going to accelerate half as much. It's going to be harder to move these bricks when there are more of them. So the acceleration is inversely proportional to the mass. That means as you increase mass, the acceleration decreases. You see that mass is on the bottom here, it's on the denominator. So now we're ready to put this together to get Newton's second law. So Newton's second law says that the acceleration is directly proportional and in the same direction as the net force, what we just saw. What this says right here, acceleration is directly proportional to the force and inversely proportional to the mass. So it's just repeating exactly what we just said, but it now gives us an equation form for this. Most of the time we will see Newton's second law rewritten as F equals ma, but I like the A equals F over m because that gives a more conceptual understanding. You increase force, acceleration increases. You increase mass, acceleration decreases. And then note the direction of the acceleration is the same as the direction of the force, which it says to here. This is just like we said that the acceleration of the velocity, the direction of the velocity was the same as the direction of the displacement. If you push something this way and that's a net force, well, it's going to accelerate in that same direction. So let's do one example using Newton's second law. And this is a good review of vector addition. You're out on the Sound in your 200 kilogram sailboat. The wind exerts a force of 1,000 newtons east, so I'll draw that. And I'll call it FA, which is 1,000. And the water current exerts a force 300 newtons 25 degrees north of east. So remember, you draw that second thing first, and then you go north of that. That means you're going this way. It's not to scale. Assume this is 25 here. And that's 300. And we'll call that FB. So those are the two forces on this boat that is what's making them move. We can ignore anything else like the weight of the boat right now. We'll talk about that stuff later. Right now, these are the only two forces causing the acceleration, which is what we're trying to find. So this is a vector addition problem. We separate the x and the y directions. We write down the x and y components of each force, FAX, FBX, FAY, FBY. You could have called these forces 1 and 2. I just called them A and B. So the x component of FA is 1,000 because it's all to the east, all to the right. So that means that FA does not have a vertical component. And I don't worry about putting units when I do the components. It just takes up more room. All the forces are Newton, so we'll be okay. And then the x component of FB here, if you draw FB here, you can see the x component is to the right, the y component is upward. So that means that the x component is adjacent to this angle here. It's going to use cosine. So 300 cosine of 25 degrees, which is equal to 272 newtons. And then FBY is going to use the sine, 300 sine of 25 degrees. That's going to give us 127 newtons. Again, you can round on the paper, but don't round until the very end when you use your calculator. So we found the x and y components of each force. Now we're going to go ahead and add the x component to get the net force in the x direction, which I'll call Fx, or I can call it sum of Fx, the net force. When you add these together, we're going to get 1272 newtons. And when we add the y forces, to get the sum of all the y forces, we're going to get 127. Note that all of my components were positive, but you do have to pay attention. If a component is going to the left or downward, make sure that you make that negative. And now we can find a net force by using the Pythagorean theorem. We have a net force in the x direction that is to the right, a net force in the y direction that is upward because they're both positive. That means the net force will be northeast, which we already knew, but maybe we didn't have a drawing of this. It's good to always draw your x and y components here. And so use Pythagorean theorem. The net force equals the square root of fx squared plus fy squared. And I got 1278 newtons. And then we need to find the direction, find this angle here. And we're going to use the inverse tangent to find this angle, as we did in the previous videos of vector addition. So inverse tangent of the y component over the x component. And that will give us about 5.7 degrees. And now let's just make sure that we answer the question. This so far just looks like a vector addition problem, but we do have to use Newton's second law because it wants the acceleration. We just found the net force, so we know that the acceleration, the vector, is equal to the net force divided by the mass. So now we can divide this 1278 by the mass, which is 200 kilograms here. And when we do that, we're going to get 6.39 meters per second squared. When you specify the acceleration, remember that acceleration is a vector, so you have to specify its direction as well, which we just said in a previous slide. The acceleration is the same as the the direction is the same as the direction of the force. So you need these two numbers for your final answer. So that's it for this video. So just to recap Newton's second law, A is equal to F over m. More force means more acceleration, more mass means less acceleration. And we'll do a lot more problems using Newton's second law in videos that follow.